Have you ever wondered how high you could leap if you were on a different planet? Imagine bounding across the rugged Martian terrain or making giant leaps over Jupiter's swirling storms. It's a thrilling concept, isn't it? But why would your jumping height change on different planets? It's all about the interplay of gravity, mass, and atmospheric pressure. Well, let's dive into the science behind it and see how gravity, mass, and atmospheric pressure affect your jumping capabilities on different heavenly bodies. Gravity! It's what keeps us grounded, literally. But what is gravity exactly? It's a force that attracts two objects toward each other. The bigger the objects, the stronger the gravitational pull. It's what makes an apple fall from a tree, or keeps the moon in orbit around the Earth. But here's the thing, gravity isn't the same everywhere. It varies from planet to planet. You see, the force of gravity on a planet is determined by its mass. The more massive the planet, the stronger its gravitational pull. This is why you weigh different amounts on different planets, and your weight, in turn, affects how high you can jump. The less you weigh, the higher you can jump. It's as simple as that. So, on a planet with less gravity, you'd weigh less and be able to jump higher. So, with varying gravity, your jumping height would also differ on each planet. But that's not all. Mass and atmospheric pressure also play their parts. Now let's unravel this a bit more. The mass of a planet is directly proportional to the gravity it exerts. The larger the mass, the stronger the gravitational pull, and the lower your jump would be. Conversely, on a planet with less mass, the gravitational pull is weaker, allowing you to jump higher. But let's not forget atmospheric pressure. It's the force exerted by the weight of the atmosphere, and can affect the energy you put into a jump. In a high-pressure atmosphere, the air is denser. This density can act like a wall, making it harder to push through and thus reducing your jump height. On the other hand, in a low-pressure atmosphere, the air is thinner and you can jump higher with the same amount of effort. Therefore, your jumping prowess doesn't just depend on gravity, but also the mass of the planet and the atmospheric pressure around you. Now let's take a hypothetical interplanetary jumping tour. Imagine you're standing on the surface of Mercury, the smallest planet in our solar system. With only about 38% of Earth's gravity, you'd find yourself leaping nearly 2.5 times higher than you could on Earth. That's a jump that could clear a tall fence with ease. Next, we whisk you away to Venus. Despite its similar size to Earth, Venus's dense atmosphere and slightly lower gravity would allow you to jump about 1.5 times higher. That's enough to get you over a basketball hoop. On Mars, you'd be a true high jumper. With just over a third of Earth's gravity and a thin atmosphere, you could potentially jump 3 times higher than on Earth. Picture clearing a single-story building in one bound. Next stop, Jupiter. But here's where things get tricky. Despite being the largest planet, its intense gravity would limit you to jumping just about a fifth of your earthly height. Think more along the lines of stepping over a small puddle. Lastly, let's visit the Moon, our closest celestial neighbor. With only 1/6 of Earth's gravity and virtually no atmosphere to slow you down, you could jump a whopping 6 times higher than on Earth. That's leaping over a parked van in a single bound. So, depending on where you are in the universe, your jumping height could range from a tiny hop to a giant leap. Isn't it fascinating to see how different planets can influence something as simple as a jump? We've embarked on an incredible journey today, exploring how gravity, mass, and atmospheric pressure shape our ability to leap into the air, from the comfort of our living room to the farthest reaches of the cosmos. Let's take a quick trip back through the stars. On Mercury, you would jump over 3 times your Earth height, thanks to its lower gravity. Mars, with its thin atmosphere and decreased gravitational pull, would let you jump twice as high as you could on Earth. And let's not forget the gas giants. On Saturn, despite its massive size, you could still manage a decent hop due to its lower density. But the true high jumper's paradise? That's our Moon, with its minimal gravity and lack of atmosphere, allowing for leaps 6 times higher than on Earth. Remember, no matter where you go in the universe, the laws of physics will always hold you down, or let you fly.